Okay, they'll introduce themselves.
So hi everyone. This is Abhishek here. I'm a software engineer at Cloudera. I've been working on Apache Ranger for over 4 years in Cloudera. I'm an Apache Ranger committer, and I also contribute to other open source projects like Atlas and Ozone. I graduated from Stony Brook University with a master's prior to joining Cloudera, and I used to work as an analyst at Goldman Sachs prior to my master's in Stony Brook. That's about me. Ramesh will introduce himself.
Yeah, I'm Ramesh Murray, software engineer from Cloudera. Before that, I was at Hortonworks, which merged with Cloudera. And I'm a PMC in Apache Ranger and a founding member of Apache Ranger. Also a committer in Apache Atlas. Yep.
So this is the outline for today. Today's talk. We'll be giving an overview of Apache Ranger, evolution of Apache Ranger, how it evolved over the years. We'll be showing a use case of Superstore Analytics, a business real-world use case where we will show how access management works right now with Ranger, and how will it go? How will it look like going forward? Then we go to the main topic of discussion, which is governed data sharing. We introduce concepts like data shares and data sets. We see data shares and data sets in creation, how they tie with each other. And then once we explain these concepts, we'll be giving a demo using a Trino SQL engine, and then we'll be using Hive SQL engine to demonstrate other use cases using GDS. And then we'll be open to questions and answers. So pass it on to Ramesh, who will be introducing Ranger.
Yeah, most of us, everybody knows that about Apache Ranger, though. I'll just give a brief on that. So it's a framework which enables, monitors and manages comprehensive data security across various services. So Ranger has its centralized administration, meaning that it manages all the authorization-related tasks in a single pane of glass where services maintains the policies, and also the authorizations are on the fine-grained access control. That means that it is like in a service. The resources are managed at the very granular layer, like in Hive case, database tables and column level authorization takes place. So it's all managed through a centralized administration panel in Ranger, and also how the authorization is like it is standard across all the components which does the authorization with the Ranger. It has the uniform panel so that there won't be any a dilemma or anything. It is like very uniform and very easy to use and precise in giving these access controls and operations across the data processing services. And then comes the the various levels of access, like role-based access, then access control based on attributes, and the flexibility to implement all these things. It provides a various flexibility to use a secure model to a specific requirements. So it is like either you can use the RBAC or you can use these attribute based, and slowly it evolved into like tag based also, which comes with the along with the RBAC access-based control system and role-based access control system. All this supports the tagging and anonymizing also. Okay, and finally, along this authorization comes the centralized auditing also. Ranger can centralize, audit all the access controls, which all have this, service which gets authorized, and as a part of the byproduct, you will authorize and it will be stored in different services as well. Okay, and within Cloudera, we have various custom plugins also for cloud, like Azure, GCS, and Amazon also. Okay, and about the evolution, Ranger itself started with the resource-based policies. What that means is like, okay, say suppose a resource like Hive, they have a service like Hive have the resource like database tables and columns. HBase have tables, column families, and associated columns. and Solar has its documents. So all these are the resources. So Ranger centralized, Ranger's administration manages all this with the centralized administration for all these resources. That is the first, first layer of whatever that evolution happened on Ranger based resource based policies. Then came the tag based policies. What that means is like there are classifications around data happening, and these classifications are happening across system and external to the system also. System like Apache, Atlas, and things like that, they classify data and they send these classification to Ranger, okay, and Ranger maintains all these classifications and policies against these classifications, and anonymize and access control through those tag based. Then now we are at an abstraction where data sets are there, curated data sets are there. Data owners create these curated data sets and give access to these curated data sets, share it with the team with the same uniform interface with the Ranger. And yeah, that is what in today's presentation is going to be, and more depth, more demos and things are going to happen with this data governed data sharing way of authorizing. Yeah. With that, I'll hand it over to Abhishek to deep dive.
Yeah, thanks, Ramesh. So here I'm covering an example of a superstore as a business use case to understand how access management works right now and how does it look going forward with governed data sharing. So we have a superstore. The superstore is geographically located in different regions of the world. And there are multiple teams which are part of the superstore. One such team is the customer data team. So the customer data team deals with all the data pertaining to the customers who are customers who purchase products from the superstore. So they have personally identifiable information as well, which is part of the data which resides in Apache Hadoop. So this team owns the data, maintains the data, and stores the data in Hadoop. So the data granularity looks something like it's on a country level and then for a calendar year across the different countries that the superstore operates in. Next, we go to another team which is also part of the superstore, which is the sales team. So the sales team deals with all the sales data, the purchases that the customers are making across various product categories. It aggregates them and keeps them in Apache Ozone. So Ozone is a distributed object store which scales much farther than Apache Hadoop. So due to different data requirements by these different teams, they store data in different storage locations. In this case, example, I have taken Apache Hadoop and Apache Ozone. So these are the two teams that we discussed so far. Here comes another team, which is the analytics team. So the analytics team comprises of analysts or data scientists. So this team typically runs analysis on various kinds of data that they have access to and performs insights or trends into the data. So now we are going to talk about Trino, because the team uses Trino on a day-to-day basis. Trino is a distributed SQL engine that can query different data sources. Here in this example, we are using Trino to query Hadoop and Ozone as well. So Trino offers a lot of different connectors that can be used to query different data sources. In this example, we are using Hive connector to connect to Hadoop and Ozone out of all other connectors that Trino offers. Trino also offers other connectors like connectors for Iceberg and cloud data sources as well. So the data sources that we have chosen here are the ones that we will be demoing later in the session. They need not be restricted to these services. It can be any service. What the feature talks about, it can be for any service that it's supported in Ranger, and not just these three services or data sources. So now we have a case of a project. We present a case where there is a project, and the aim of the project is to get insights into last 2 quarters of data, of sales data, essentially the purchases that were made by the customers, what product categories were purchased by the customers, get insights into them so that they can help sales drive more revenue in the coming quarters. So there's a project manager who is associated with this project. The project manager happens to be as part of the analytics team. So the project manager has access to resources in Trino. But for this project, there are a new set of people who are going to onboard onto this project. On the left, there are a new set of people. So these new set of people don't have access to any resources in any of these data sources. So how do they get access is what we are going to discuss. How does access management look like for them right now, and how will it look like going forward? So how it looks right now is you have resource-based policies. So you go in Ranger, as we saw in the earlier slide, you have resources for different services. So you go there and you edit policies for the, you check the policies, what are the policies, and then edit policies and try to add users to respective services. So as we will see, this becomes quite cumbersome if number of resources are pretty large, or there are a lot of different services that for which people need to be given access to. So in that case, it would be very helpful if Ranger governed data sharing comes into the picture. So with this feature, we introduce concepts like data share and data set. So going forward, the data sources are clubbed into 3 data shares, as you can see: HDFS data share, Ozone data share, and Trino data share. And then all of this is combined in one data set, which we refer to here as analytics data set. So the project manager creates the data set, and with the use of the data set, access is granted to the new set of people very conveniently. And this becomes very easy to grant access as well as to revoke access to the set of people. Yeah, so we go to, so this is the feature that we'll be talking about, governed data sharing. So in the next major release, this will be rolling out, and you can see that as a new module on the left pane. There are a few things that are part of this, which are data sets, data shares, and requests. I will cover all of them one by one. So in a nutshell, this is simplified data governance across a whole range of services. We'll be introducing concepts like data shares and data sets. And then we'll be showing dynamic sharing. How does that work with data shares in context of data set? We also have this feature of time-based access control. So when data shares get created and they are requested to be part of the data set, you can restrict time on them. So let's say 6 months. So after 6 months, the access gets automatically revoked. We will cover that in the demo. And we go to the next one, where we define what a data share is. So a data share is a curated collection of shareable resources for a particular data source or data service. So the data source can be HDFS, the data source can be Trino, the data source can be Kafka. It's a collection of shareable resources. So resources are particular for a service. So for HDFS, it will be an HDFS path. For Trino, it can be a catalog, it can be a schema, it can be a catalog, schema, column, table, or catalog, schema, table, column. For Kafka, it will be a topic, so on and so forth. Who are the people who create data shares? So the data owners, who are maintainers of the data or who are owners of the data, or also refer to them as data stewards, they create the data share, or they can share the data share to be made visible to other data owners. And these are the people who add resources to a data share so that this can be used for access management. So this is the part of the data share creation process. So we go to Ranger, log into Ranger, go to govern data sharing, and then you try to create a data share. So here you give a name of the data share. So here it is customer data for 2024. Then you pick a service where this data resides. So in this case, the data resides in HDFS. So you give an instance of the service, which is dev HDFS. And then in the bottom section, you just describe what this data means so that anyone looking into it, when they log into Ranger, can see what this means. So it means curated data for all first-time customers who joined the Superstore in 2024 across all regions. So now we go into the last step of the data share creation process. So there are a couple of steps involved here. I'll be skipping over them in the interest of time. So in the last step, there is a create data share at the top right, where you go and create the data share. This process that we see here is via Ranger UI, but we do also have REST APIs to do the same things. You can use curl or you can use Python client that we have. So you can just go and search for Apache Ranger PyPy, and so we have a Python package for Apache Ranger there. You can use Python to query and create data shares. This is a critical aspect of data share. You add resources to a data share. Only when a data share has been created, you can add resources to a data share. So in this case, I've taken an example of Ozone data share, where I'm adding resources to the data share. So there are like 6 resources, as you can see here. So Ozone has this hierarchy of volume, bucket, and keys. So here for the customer data across different countries, you can see that the countries correspond to the bucket and the key correspond to the calendar year for which the data is. And in the access type, you can see that this is read permissions on these resources. So that's just about it for data share and what it pertains to. Now we will be taking a look at what data shares look like for different users. So this is an admin in the Europe region. So when this person logs in, the person can see that this is a data share that is either the person has access to or it was created by the person. So it's a data share for Europe region and it's tied to the Ozone service, so meaning that all the customer data for Europe region is residing in Ozone. Now there's another admin in the Asia region. So when this admin logs in, the data shares that can be seen are just one data share for HDFS service, and this is for all data residing in Asia region. So now we have another data share. So an analyst logs in. Analysts typically, in our use cases, they run and do their analysis on Trino. So they can see the data shares which accesses data residing in Trino. So in this case, it's an Analytics 2024 data share for Trino service. Now we define what a data set is, and then we tie data shares and data set to make meaning out of it and how it works together. So a data set is created by a dataset admin for a specific purpose. It's a collection of one or more data shares. It grants access to users, groups, and roles. So dataset is the level of abstraction at which the access is granted. But dataset need to have data shares in them so that access is granted to people for the resources that are part of the data shares. So here we have an example of Superstore Analytics as one of the data sets. We can see on the right, we can see what are the data shares which are part of the data set. It says 3 active. So there are 3 active data shares which are part of the data set. And right now it's just shared with one user. So that's an aggregate, like a high level overview of the data set once the data set creation is done and the user is able to see the data set. So the dataset creation process is very similar to how it happens for data share. You give a name of the data set. In this case, it is Superstore Analytics, and then give a description of what this data set means. So it means to run analytics on customer trends for Superstore sales across regions. And then after a couple of steps, you get an option of creating the data set, and you're done. After a data set has been created, this is a critical aspect where you request for data shares. So the dataset admin is the data consumer. He's trying to consume the data. When trying to consume the data, you have to request data from respective data shares. So if you see on the in the rear part of the screen in the snippet here, there is a data shares and there is an option of adding a data share. So once that option is clicked, the dataset admin can see all the data shares which are visible to the data set admin, and then select the ones that are required to be part of this data set. So there is a small icon on the right, which when you hover on it, you can see what is the description of the data share. What does this data mean? So there's a description. So people who would be like the data owners, they would, when they have created the data share, they would have given a description. It helps the data set admin know that is this the right kind of data that I should be requesting in the data set or not? And then there's an option of send request. Once the send request is clicked, the request goes to the different data owners so that they can approve or deny if this data share would be part of the data set or not. So now we have another thing in Ranger. So in governed data sharing, there's another option of which says my requests. So this is what it appears to the data share admin. So this admin is the data owner for America's data share, and in this request, it can be seen that this was requested to be part of this data set by dataset admin. And once you click on the ID, the data share admin has an option of either granting access or denying access. So once the grant happens, this is one part of the two-way handshake. So the request goes to the data owner approves it, and then the dataset admin checks in the same request by logging in that it was granted, and then an option of accepting it and making it active. Making it active is essential and crucial part. Once the data share is active in a data set, then that can be used for access management. So now we go into a demo which will explain all the things that we discussed so far, and including the business use case that we saw earlier as to how it ties things all together and makes it very convenient for people to receive access and also revoke access. So, sorry. Yeah. So we use Docker for all the setup that you see here in the demo. So it's all Docker-based setup. We are running multiple containers for different services like Trino, HDFS, and Ozone, and Ranger as well. And we do a Docker exec into the Trino container as a Trino super user to see what are the resources that are there. So we can see customer data table and the sales table. So in sales table, we can see what this table is all about. So this table is all about the different purchases made by the customers. It's an aggregate on the different purchases, different across different product categories in the superstore. So here we can see that this is referencing an OFS location. So this essentially means that this data is sitting in Ozone in Parquet format. And we have another table, which is customer data table. So this table is residing in HDFS. This is also stored in Parquet format, but this is customer data. And the earlier that we saw was sales data. So there are different data for different tables residing in different storage locations. So now we have an idea about the data. Now we go back into Ranger. And this is the dataset admin logging in. And this is the name of the dataset, Superstore Analytics. We can see that there are 3 data shares which are part of this data set. So you see Analytics 2024 for Trino, customer data for HDFS, sales data for Ozone. So there's this 4th column you can see. These are the resources that are part of this data share. So there are 3 resources in data share for Ozone, 1 for HDFS, and 8 for Trino. There's a small little icon on the right side. If you click on that, one second. I think it went over again. Yeah, that's okay. Yeah, so if we click on the right icon, we can see what are the data, what are the resources which are part of the data share. So for Ozone, we see that there are 3 resources, 1 for volume bucket, and 1 for volume bucket key. And it specifies read permissions on these resources. And then we go to another data share, which is for HDFS, and we see that the resources that are tied to this is an HDFS path, which is also the Parquet file that we saw earlier in the schema. And then we go to the last data share, which is the Trino data share. Here we see that there are 8 resources. So as we saw earlier, Trino has this hierarchy of catalog, schema, table, and columns. So here there are resources like column and tables on which the access is given for read. So you can see that there are read permissions on the customer data table and also the sales table. So now we go back and we go to the most important aspect of granting access. So this is where the access grants happen, meaning this is the place in the data set which gives access to people. It can be users, it can be groups, or it can be roles. Because in Ranger, access can be granted to all three of them. So right now we have users which are analysts who already have read access to the data set, meaning they can access anything which is part of this data set, which are the three data shares that we just saw earlier. So now what we are going to do is we'll go back to Trino CLI and we will try to run some commands. So as you can see, we are exiting and we are making an exec into the Trino container as a data scientist. On the bottom of the screen, you can see the data scientist is trying to log in and tries to perform a query here. So this query is a join between two different tables. And it's doing a correlation on the result of the join. So we are trying to get some analysis on this data. So that's why we are running the correlation query. So this data scientist tries to run this query, and all that happens is access denied because the data scientist was not granted access to the data set. So now we go back into Ranger and we try to give data scientist permissions. So the dataset admin, who is the owner of the dataset, goes and types in the username or the group name or the role name. In this case, it is data scientist, so data scientist, and then clicks on save. So once you click on save, the user is granted access. And we go back to Trino CLI and we try to run the same command again. And this time the query goes through. So we will come back as to what happened behind the scenes a little bit from now, but we will just explain what happened here. So this is a correlation query running across different columns and different tables. So to get some meaning out of it, this is just a sample query. So what the data scientist sees is that there is a strong correlation between the income of the customers to the number of wines purchased, and also to the number of meat products purchased. So there's a strong correlation. You can see 0.57 and 0.58. But there's not a very strong correlation with the amount of fruits purchased. That's a weak correlation. So that is some kind of analysis on the data, which is residing in different data sources using Trino queries, using the correlation command in Trino, but that happens on a join after the two tables, join on the two tables. So now we go back into Ranger to see what actually happened in Ranger. So Ranger, when you log in as an administrator, you can see the access audits. You can see audits for everything that Ranger authorized or didn't authorize. So these audits are coming from Solar. So Solar is the default destination for all the audits that are kept in Ranger. So there are multiple audit destinations that Ranger supports. This is one of them. And you can see here that we will try to refresh this page here. Yeah, just in a little bit. Yeah, so we can see that in the fourth column, we can see that data scientist is a user who is trying to run the query. And as part of the query, there are multiple resources that the query required. And the data scientist was granted access to ozone resources, as you can see in the first row, and then the second row also an ozone resource. And the third row is for an HDFS resource, that's the Parquet file that is being granted access to. And then in the fifth row onwards, you can see that there are Trino resources like catalog, column level access is being granted to this user. So there are a whole bunch of different resources that user was granted to in just one click. So that is the power of data sets and data shares. You can see in the last column, it says Superstore Analytics. So this data set is actually giving access to this user. If you click on the policy ID, because there is a policy associated with a data set, so if you click on the policy ID, you can see that this is a GDS policy, which is the government data sharing policy, and this is the Superstore Analytics that this policy is associated with, and this is granting access to it. So that's where we conclude the demo. And one more thing we would like to show is how the revocation of access happens. So as simple as it was to give access, it's the same for revoking access as well. So we try to revoke access here. So the data scientist is no longer as part of the grants. access grant is updated. Now we go back to Trino CLI, and we try to run the same join query and try to run the correlation. And this time, it says access denied because we just saw that the access was revoked for this user. Also, in this case, we are using Trino CLI to access all the resources in the backend, but it need not be so because using this feature, the user can directly run HDFS commands, that a user can directly go and run Ozone CLI commands, and the same authorization would work in that case. Here, Trino is kind of like doing that in the background for you, because when you do a join, you do access resources in Ozone, you do access resources in HDFS, and it's doing for you. But the same user can go and log in into three different shells and run and directly access the resources, and the GDS dataset policy would still work in that case. So this is where I conclude the demo, and I will pass it on to Ramesh, who will be explaining features like column masking and row filters.
Yeah. So one of the key feature of Ranger is like anonymization. So we anonymize data which are queried by setting policies. So column masking and row filtering, normally in the earlier abstractions like resource level, you can do that. And tag-based policies, on the tag level, you can associate this column masking. Now with this GDS abstraction in place, you can define column masking and row filtering. Currently in this release, actually, it is in work in progress. We do it via API. Okay, so we maintain this masking at the resource level. Abhishek showed that there is a data share. There is a data share associated to it in the data set, and these data shares have various resources in it. Okay, say example, in this case, Hive will have some set of tables in there, and we are going to anonymize, saying I'm going to mask a column, and also I'm going to filter a column, for some users. Okay, so and this is done at the GDS level. Okay, currently this feature is on the GDS level is supported on the Hive query. Okay, so with this I'll show a demo. So here what happens is like, if you go, I have maintained a data set called patients data, where it has a data sets where data shares are there, like patient info, and the diagnosis data share is there, under which there are some resources. Like in this case, there is a table called patients under a database, medical analytics. So in this one, we grant access to a user called Alice. Okay. So if you look into the grant access, here we grant access to that particular table for user Alice and read access to that table. Okay, and also behind the scene, we used an API to anonymize the data. Okay, so that one is currently it is in the API. Since it is an API way, we have a log there. Okay, which says that all these filters are there visible in that log. So let's go to that admin log, where I want to show that in the API, if you see, there is the resource, which is a table called patients, in which Alice has access to read, and there is a filter associated to it. So the filter is like, the row is filtered, like having an expression where only the rows which have which belongs to state Washington is given to the user Alice. And also one more anonymization is the masking. Okay, here if you see this one, the birth date in the table is masked with null. So this is one a typical example of like how we are giving a policy for for a resource on a GDS level abstraction. So once this is set up, okay, I want to show one more policy where a normal user, okay, he has an access to that same table, okay, the patient's table under meta-analytics database, okay, and he has all access. This Abram has all access. He or she has all access. So once we go into and query that in Hive, here the user Abram has all access. So when he uses that database and queries that particular table, here show tape definitely he has only access to this particular patient's table. That's why only one table is shown. When he queries, he has every access and all the columns without any restrictions or anything. So no anonymization and no filtering. But whereas when the user Alice goes and executes the same query the same way, uses that mid analytics and show tables, user has only patient's table access, and when the user queries the table, you will see that anonymized data. If you see this one, the birth date is nullified, and also the filter, the Washington state alone is shown to that user. So yeah, that's how the feature of anonymization works with the GDS level as well. So and also you see that byproduct is auditing. So all these policies which took the decision to do the anonymization all will come up, and if you go see that, okay, if you see that 39 policy gave read access, at the same time there will be audits which shows, okay, which policy masked the data, which policy did the row filtering for that particular user, and also the other policies. This is the regular policy which give whole access to that another user called Abram. Okay. Yeah, with that I'll conclude this demo of row filtering and anonymization basically in Ranger. Yeah. And yeah.
Thanks, Ramesh. So that's all we had for this session. This is the Jira, which tracks all the work which went behind this new feature. And these are the resources you can use if you have any questions. We can. Sorry?
Is it already released, the feature?
No, it's going to be released.
Yeah, it is going to be released in the coming release.
Next major release. Yeah.
Yeah. So we can go for it.
Thanks, everybody.
Yeah, if nothing else, thanks for, and feel free to contribute.
Now everybody has a lunch break. The sessions will pick back up at, I believe,